This is a great question. We've got a puzzle and we're trying to work out how many solutions there are to it. So the circles add up to all of the four surrounding squares in each case. So the first thing I'm going to do is just going to label the squares A, B, C, D, E, F, G, H, I. And I can construct four equations. So these add to 22. These to 28. Now, actually, what we have are 9 unknowns and 4 equations. So there is no unique solution in general to this. But because we have a restriction that A, B, C, D, E, F, G, H, I must be between 1 and 9, and actually, they can't be repeated or anything, then essentially we've got like a complicated system of Diophantine equations. And we can try and solve these. Now, we don't actually want to just go ahead and start combining them. Actually, it's good to think about a couple in particular. And one that jumps out is this third one here, because it adds up to the smallest amount. If you take the four smallest numbers, 1, 2, 3, and 4 that we can have, then we're going to get 10, which is only one off this number here. So the only way that we can get 11 is if we change that 4 to a 5. And that means that D, E, G, H are going to be 1, 2, 3, and 5 in some order. We can do very similar for the largest number. So if we look at the largest that we could obtain, remember the largest is 9, then this is 17 plus 13, 30. Okay, so to get 28, I'm going to need to have 7, and then actually it'd be 4. Would that work? 17, yeah, that would work. Or I could go with 9 plus 8 plus 6 plus 5. There's no other way I can do it. If I get rid of the 9, then the biggest I could do is 8 plus 7 plus 6 plus 5. That would be too small because you already see that, I need a 9 here. So if I replace the 9 by 7, I'd only be able to get 26. If I replace the 8, then I'm not going to be able to get there either. Because if I put a 7 in there, then again, I'm not going to have enough. So it's going to be one of these two options. And that means that B, C, E, F are going to be 5, 6, 8, and 9 in some order. Now note that E is in both, E here and E here. So E has to be in both lists, and there's only one number that is in both lists. Okay, so we've got our first number. Brilliant. E is equal to 5. Right, let's just kind of write this out again, take stock of where we are. So at the moment, we know that, have I labeled that right? Yes. We know that D, G, and H are now going to be, because I've got the 5, going to be 1, 2, and 3 in some order. So that's just a little bit of writing to remind me about that. And then B C, and F are going to be 9, 8, and 6 in some order. Now what that leaves is 4 and 7. Now, let's look at if F, sorry, not F, if 4 and 7, and also this must be A and I. Sorry, I didn't say that. But I've dealt with these three and these three. These 4 and 7. These must be A and I. Now let's look at the situation. If I was equal to 7, then E plus F plus H plus I would equal 5. We know E has to be 5, plus F plus H plus 7. But remember, the smallest the F can be is 6. F has got to be greater or equal to 6. So this is going to be greater or equal to 18. And this is not possible since H cannot equal 0. And therefore, A must be 7 and I must equal 4. Nice one, another 2 found. So I'm just going to draw on my updated list. I've got 7 here, 4 here, 5 here, and then B, C, D, F, G, H. Right, next up, I'm going to focus on F. F can take a choice of 3 numbers. First one would be if it was the largest, if F is equal to 9. Then in that case, H would have to equal 0. So this is not possible. What about if F is equal to 8? Then H is equal to 1. Okay, so let's just imagine that scenario for a minute. Then we'd have to have D equal to 2 or 3, because G is also equal to 2 or 3. Okay, we've got sort of a long line of argument here. We're looking at the situation where F is equal to 8, which means that H is equal to 1, which means that D is equal to 2 or 3. And then if D is equal to 2, then B would have to equal, I'd get 14, it would have to equal 8. But that's not possible because F is equal to 8. Okay, I'm explaining it verbally. I would write that down in the real thing, but it's not possible. And if D is equal to 3, then B would have to equal 7. But we've already used 7 up, so that's not possible either. And therefore, it must be that F is equal to 6. If this is going to work, we've not actually shown it yet. So assume this works. There's not going to be the issues that we have because it's a smaller number. Right, I think it's time to update our table again because actually, what else can we find? So then we've got 5. Actually, I don't need to put that in yet. We've got 5, 4, just said that F is 6. This is 7. B, C, D, G. And therefore, H, okay, to get to 18, we've got 11, we've got 15. H is going to have to equal 3. Okay, so I can fill that in as well. Oh, quite long this question, but obviously, it's meant to be challenging. We worked out E, we then worked out A and I, we used a sort of showed that it couldn't be 7 bottom right, it had to be 4. These were the remaining ones. Then we made an argument about F, showed that it couldn't be 9 or 8. We put 6 in and got the value of H. And now we're just left with B, C, D, and G. So I'm kind of going to start from the beginning, really. I'm not going to look at the equations that I wrote earlier. B plus C must equal, well, I've got 11 here, so they've got to equal 17. And then D plus G, I've got 8, they must equal 3. So we're going to have 8 and 9 in some order here, and 1 and 2. But then I've got one other condition, and that is that, D plus B must equal 10. So let's look at the possibilities for this equation. We know that D must be 1 or 2, so let's look at that scenario. So if D is equal to 1, then we're going to get, first of all, let's look at the pair. To get 10, B will have to equal 9. And to get 3 here, G will equal 2. And then to get 17, C will equal 8. So that's going to be one solution. And then if D is equal to 2, let's see if we get one here as well. Then B must equal 8 to add to 10. G will equal 1 to add to 3. And C will equal 9. And these equations will be satisfied for both of these cases. So there are two solutions. Let's just finally get these solutions down. Remember, both of them have 5 in the middle. They both have 4 on the bottom right and 7 top left. They both have 6 here, which means that we've got 3 here. And then we've just got these two scenarios. D was equal to 1, and then G was equal to 2. And in that case, when D is 1, we had B equal to 9 and C equal to 8. Or D is equal to 2, G is equal to 1, B is equal to 8, and C is equal to 9. You could even just double check and see that it works. We've got, in both cases, 15 plus 7. Sorry. Oh, I think I've made a mistake. No, I haven't. 15 plus 7 and 16 plus 6. That's going to give 22. 17 plus 11. In both cases, 28. 11, or these are the same. 11 plus 7 gives 18. And then 7 plus 4, 11. And 6 plus 5, 11. So two solutions. There they are. Well done with this question.